Hi everyone. I'm going to work out the following problems, but I'm not calculating the final solution. I'm just doing the setup. You guys can plug in the numbers into your calculator to check your answer, or actually check the answer key I uploaded separate to get the final answer. So in the first part, state if each scenario involves a permutation or combination. In both cases, we want to select a group of people, or a group of objects. However, in one, if the order is irrelevant, it's a combination. If the order does matter, we call that a permutation. A team of 8 basketball players needs to choose a captain and a co-captain. So out of the 8 basketball players, we need to choose 2 people. One for captain, one for co-captain. The order matters. It's not the same being captain versus co-captain. All we need to say here is permutation. Next one, Rob and Mary are planning trips to 9 countries this year. There are 13 countries they would like to visit. They are decided which countries to skip. Out of 13, they're only visiting 9, meaning that there are 4 countries they won't visit. Since they're going to skip them, it doesn't matter in the order in which they skip them, since they're never going to go anyways. So that's a combination. Order does not matter. The batting order for 7 players on a 12-person team. If you're going to be batting in a baseball game, you want the order. It's specifically saying order, so it is a permutation. There are 45 applicants for 3 computer programmer positions. 45 applicants for 3 positions. The positions are identical. Everybody will have the same job. So order does not matter, meaning that this is a combination. Now, besides stating if it's a combination or permutation, which I will only say P for permutation or C for combination, we need to find the number of possibilities. Okay? So, Gaston and Joe are planning trips to 3 countries this year. There are 7 countries they would like to visit. One trip will be 1 week long, another 2 days, and the other 2 weeks. So 3 different trips. It's not in the same trip. 3 different trips, and each one lasts a different thing. It's not the same as if you go on a puente to Valle and summer vacation to Paris versus a puente to Paris and summer vacation to Valle. It's a very different thing, so order does matter. So this is a permutation. And out of the 7 countries, you will only visit 3. 1, 2, 3 out of 7 countries, so 7 times 6 times 5. No division done here. Remember, I am not filling out the final value. You can do that yourself or check my other answer key. There are 110 people at a meeting. They each shake hands with everyone else. How many handshakes were there? So, yes, you could think about handshakes. You shake this person's hand, and this person shakes another person's hand, etc. But more than that is, if you realize once these people shake hands, these 2, that's one group. The order in which they shake is the same. Once they shook hands, it happened. This is another group, another possible group of shaking hands, and this is another one. So what we're doing, the order doesn't matter. So this is a combination. It's as if I tell you, out of the 110 people, how many ways can I just pick 2 at a time? So it's a combination, and out of 110 I pick 2. 110 times 109. And since it's a combination, I divide by 2 times 1. Simplify and work it out. You are setting the combination on a 3-digit lock. You want to use the numbers 1, 2, 3, but don't care what order they are in. Okay, a combination. Here it's saying the word combination. This one's actually a bit tricky. Because typically in a 3-digit lock, even though it's called the combination for lock, it's not a combination, it's a permutation, because the password 123 is not the same as the password 231. The order in which you put them does matter. So you want to use the numbers 1, 2, 3, but don't care what order they are in. This is a bit weirdly worded. I want to specify it the following way. If you have the 3 numbers, here you have 3 options for this number. Here you have 3 options for the other one. And you have 3 options for the other one. So, as per usual, we're going to have 3 to the third combinations, well, different passwords, which is 27. A group of 25 people are going on to run a race. The top 8 finishers advance to the finals. Here, this is the key word, top 8. I don't care who's first place or who's 8th place. Everybody that came in the top 8 goes to the finals. I just want to know how many different ways I can get finals. So I have 1, 2, 3, 4, 5, 6, 7, 8. The order does not matter. It's a combination. I don't care if I came in first place or 8th place here. I just care if I finish first in the finals. So it's 25, 24, 23, 22, 21, 20, 19, 18. Dividing by the ways I can order 8 people. 1, 2, 3, 4, 5, 6, 7, and 8. Now, before moving on to the next one, I want to use this as an example to simplify. To simplify it, my recommendation is always get 2 numbers. Well, cancel out anything that repeats. In this case, nothing repeats on the top and the bottom. However, using numbers on the bottom, I can make numbers from the top. For example, 3 times 7 gives me 21. I cancel these together. I can also cancel out 5 times 4, that gives me 20. I also know that 2 simplifies with 22, giving me 11. I also know that 6 simplifies with 18, giving me 3. I also know that 24 and 8 simplify, giving me 3. And since I cancelled out everything on the bottom, all you need to do is multiply the numbers left over on the top. The 1 didn't cancel out, but it doesn't matter if you divide by 1, so you can just ignore it. Next one. A team of 17 softball players needs to choose 3 players to refill the water cooler. It doesn't matter who I choose, everybody's going to refill it in the same way, so order does not matter, so it's a combination. So I need to pick 3 people out of the 17. Since it's a combination, I need to divide out the orderings of 3 people, so 3 times 2 times 1. 5 out of 13 students will ride in a car instead of a van. I don't care how they sit in the car as long as they're sitting in the car. So it's a combination because order does not matter. So 1, 2, 3, 4, 5, and I have 13, 12, 11, 10, 9. And I need to divide out the order. So 5, 4, 3, 2, 1. And again, remember, here we can cancel stuff out. 4 times 3 gives me 12. 5 times 2 gives me 10. And then I just multiply my remaining numbers, 13, 11, and 9. The student body of 10 people wants to elect a president, vice president, secretary, and treasurer. Here they're choosing people for Stuco. Is it the same thing to be the president or the vice president? No, it's different. So is the secretary and treasurer. It's different positions. So order does matter. It's a permutation. And I want 1, 2, 3, 4 positions. So I have 10, 9, 8, 7, whatever this product gives me. Selecting which 7 players will be in the batting order on an 11-person team. If I want batting order, I do care if I'm the first one up to the batting range or if I'm the last one, so order does matter. So it's out of 11 people, 7 players out of 11. So 1, 2, 3, 4, 5, 6, 7, 11, 10, 9, 8, 7, 6, 5. Multiply that and it'll give me an answer. There are 15 applicants for 4 jobs: computer programmer, software tester, manager, and systems engineer. This is exactly the same scenario as the Stuco one. 4 different people, 4 different positions. So 1, 2, 3, 4. However, it's 15 applicants. 15, 14, 13, 12. Multiply it and see what that gives us. And the last problem. A group of 45 people are going to run a race. The top 3 runners are in gold, silver, and bronze medals. So not only top 3, but I want to see what they earn: gold, silver, bronze. So order does matter. I have 45, I have 44, and then I have 43. Multiply them together and it'll give you your answers.